Hey everyone, today we're going to be talking about the power rule. So to begin, let's talk about what the power rule is actually referring to. What it is we're looking for a general derivative rule for any power function. And a power function is just some variable raised to some power. And this can also be multiplied by a constant. The general form of a function like this would be f of x is equal to n times x to the a, where n is your constant and a is your power. Some examples of this are 2 times x to the third power, 3 times x to the 1/2 power, 4 times x to the negative 1 power, and even something like 1 times x to the I power. When you have something raised to a complex or imaginary power, it's usually called a complex power function. Most of the time you won't be dealing with a complex power function in basic calculus classes, but it might come up later, and the same rule will still apply for any type of power function's derivative. So, to begin our proof, let's start by establishing our function f of x is equal to n times x to the a power. And just like we did for logarithmic and exponential functions, what we're going to do is take the natural log of both sides. It's a really useful tool for trying to prove derivatives, and it comes up a lot because we already know the derivative of something like the natural log of some input. So trying to incorporate it into other derivative problems is a really useful tool. So once we have this, we'll have the natural log of f of x is equal to, and what we need to do is take out our power, and we'll do that by taking the 8th root, not to be confused with the number 8, it happens to be called the letter a in this case, so we'll have a times the natural log of the 8th root of n times x. And from here, we can take the derivative of both sides. So we'll have on the left side, the derivative of the natural log of f of x is equal to 1 over f of x times f prime of x. And on the right side, we'll have our constant a times 1 over our input on the right side, which is the 8th root of n times x, and then times the derivative of our input, which is the 8th root of n. From here, what we can do is cancel our 8th roots of n on the right side and bring our f of x to the right side. So we'll have f prime of x is equal to a times f of x divided by x. Now we can substitute f of x for what it's equal to. So we'll have f prime of x is equal to a times n times x to the a, all divided by x. Now, if you remember how exponential rules work, if you have the variable raised to some power and then divided by that variable, all it is saying is that you're just having the original function, but you're taking away one from the original power. And what you'll have is actually the answer for the derivative of a power function, which is f prime of x is equal to a times n times x to the a minus 1. And this is called the power rule. So now that we have our power rule, let's try and go through some examples of problems where you might have to use this derivative rule. So if we have some function f of x is equal to 4 times x to the 1, well, one way you could go about this problem is by knowing that this is a linear function, and the derivative of a linear function is just the slope, so you would have 4. But if you wanted to use the power rule, then you can take the derivative of both sides, and you'll have f prime of x is equal to the power, which is 1, times the original function, which is 4x to the 1, and then you're going to subtract 1 from the exponent. So you're going to have 4x to the 0, which is just 4. Another example where we can't use just the slope of the graph to determine what the derivative is. If we had f of x is equal to 3x to the 4th power, f prime of x would be equal to the power 4 times the original function, 3x to the 4, and then minus 1 from the power. So you end up having 12x to the third power. An example of a power that's not a whole number, so a fraction, f of x is equal to negative 2x to the 2/5 power. F prime of x would be equal to 2/5 times negative 2x to the 2/5 minus 1, and you end up having negative 4/5 times x to the negative 3/5. And finally, an example where the power is already negative, so f of x is equal to 8x to the negative 1. The derivative of this function would be f prime of x is equal to negative 1 times 8x to the negative 1 minus 1, which is equal to negative 8x to the negative 2 power. Make sure when you're taking the derivative and using the power rule that you don't accidentally slip up in your algebra and say negative 1 minus 1 is equal to 0, or negative 3 minus 1 is equal to negative 2. It happens a lot. I know that especially when I was first doing the power rule, I would get confused sometimes and just mess up in algebra. So make sure, especially with AP tests coming up, that you don't make these silly mistakes, because it can cost points sometimes. Thank you guys for watching. I hope that this video was helpful and the other learned where the power rule comes from, or that you at least got a nice refresher and got to practice incorporating the power rule into calculus problems. Be sure to comment down below what you want to see in future videos. I know that AP tests are coming up, so I wish you guys all well for all of your AP tests. I hope you guys get the scores that you want to get, and until then, I'll see you in the next video.